And so when I declare this type object, I give it a name and I say size of player T. So that says how many bytes of memory do objects of this type need. And then the other thing I've done is I've got an array of members. So this tells Python what members of player objects should be exposed to scripts. Now, you can actually write your own get and set method. So every time someone says player.x equals whatever, it calls a C function, and then you can do your own logic to update the object then. But to simplify things, if all it is it's a direct mapping to field with the object, you can specify an array of structs specifying what the members are. So you have the name, you have the type, and then you have the offset within the structure of that variable. So remember with C, when you dynamically allocate a structure in memory, the layout of that structure mirrors what you write in your header file, and you can access a variable just by going to the memory address of the object plus the offset of that field within that object. So you don't actually have to know the name of the field. Now, when you're programming in C, of course, you always want to use field values, but by telling Python where in memory, relative to the start of the object, that field is located, it can automatically know where to store the value when the player plays the live values. And I've done similar things for enemy objects as well. And one thing I've also done with enemy objects is I've got a list of methods. So you can call the fire method on the enemy object. And that's defined down here. I'll talk about this in a minute. So once I've defined those structs, I need to initialize them. Now, just for convenience, I've written a function called the hit simple type here. If you wanted to, you could just duplicate this code for each type you wanted to do. So I say I want to initialize a type called player. The size of this type is size of player, and then I pass pointers to the structure which define the memory. So this is how I initialize those types. So that means that Python now knows about objects of type player and also objects of type enemy. Now, I'm just going to talk about this fire method. So with the enemy fire method, I can call that from Python, of course. That takes a double as a parameter. So let me just give an example of modifying the script to do more firing. So supposing I wanted to have all enemies fire every frame. So I could say e.fire, and supposing I want to fire downwards. So that's an angle of 2 times 1.5 times height. Because if you remember from trigonometry in high school, with the unit circle, you have 0 degrees, then you have 90. Well, if you can talk about it in degrees, so it's 0, 90, 180, 270, 360, or you can talk about it in radians, where it goes to 0, pi on 2, pi, 3 pi on 2, and then back to 2 pi. So this angle is expressed in radians. So now I'm making every enemy fire downwards. And you can see that's going to be pretty hazardous to the player's health. So when I call that method, it does parse tupleton again, so that converts it from a Python value into a C value of the appropriate type. And what I also do is I make sure the type that's passed in as self is actually an enemy. Because if you're clever about how you do it, you could actually cause this to be called another type of object. But that's just a sanity check. If you want to return an error for these functions, you can use high error format, and then you just return null, and then that will pass error back to the script which you saw here. So now that I've got the angle as a C value, then I can do the normal stuff in C and call the function. Okay, so essentially the main two ways that I've used to interface Python and C here is that I've declared a global module with some globally accessible functions in here. So this is to do things which apply to the game as a whole, like add enemy and remove enemy. And then I've exposed these individual object types here. So the script can work with player objects, and they can also work with enemy objects. One final thing I should mention is how these get created. So if I go into my code where I create a new enemy, I've got a function called create enemy object. Okay, so you can't just call malloc here because in addition to allocating memory, the fields of that structure which correspond to the Python object fields also need to be initialized. So these things, which are, there's actually multiple fields that corresponds to, less in player, but it's the same thing in enemy, they have to be initialized. So if I look at this create enemy object, which is defined in python.c, somewhere, this calls this thing called PyType generic new, and that just says to Python create a new instance of the enemy type. And Python knows based on the fields of that structure how big these objects are in terms of memory, and it will allocate enough memory for it, and it will initialize the object fields, and then it will return the pointer. So after that, I've created an enemy object. So that's a Python object and a C object, right? There's one object that's used for both purposes. The reason I can use it for both purposes is that I have those Python-specific fields at the start of the structure. If this casts a pointer from enemy to Py object, and it just accesses the fields that are in Py object, this will still work because the offsets for all of those fields are the same as the offsets of the fields in the enemy T structure. Okay, so with casting in C, you can essentially get a subtype by doing this. Okay, is there any questions? Python itself comes with a library that lets you do that, so it's just Python. The Python itself is written in C, so the way that the internal functions to do things like opening files and all of that is implemented in the same sort of way as what I've just showed you inside Python. And you can actually write your own Python modules using the same technique. Sorry? No, what's that? Okay. I haven't looked at this. I only started looking into how to do this yesterday, so I haven't spent too much. Cool. Oh, there you go. So I just wasted an hour. Right. Maybe I can add a feature to the game and show you how I try about doing that. Have anybody got a feature they'd like to add? Would anybody like to have? Right? Sorry? Yep. Okay. Does anybody actually want to have a go at that? Because you can do that.